distortion in amplifier. Now the amplified output signal waveform must be exactly to the wave shape of the input signal applied to the amplifier. But undesirable changes in the wave shape of the output signal in the amplifier is known as a distortion in the amplifier. So there are different types of distortion occurs in the amplifier. First, frequency distortion. Second, phase distortion. Third, harmonic amplitude or nonlinear distortion. First, frequency distortion. Now this signal is not perfectly sinusoidal, but this signals made of many numbers of sinusoidal signal. Now these different sinusoidal signals have different frequency, and the amplifier, all the components of this DC components will not be equally amplified by the amplifier. Now this due to this, the amplifier of the gain is reduced. So now when all the frequency in the of the input signal will not be equally amplified by the amplifier, that's why it is called frequency distortion. Second, phase distortion. Now the angle between the input wave shape of the signal and the output wave shape is zero. That means there is no angle. That's why it is called the output of this amplifier will be distortionless. But if there is a phase angle between input waveform signal and output waveform signal is called frequency distortion. Third, harmonic amplitude or nonlinear distortion. Now the active devices used in the amplifier characteristic should be linear. If the characteristics is linear, then the output signal waveform is exactly or similar to the wave shape of the input signal in the amplifier. That means there is no distortion occurs in the output signal. But if the characteristics is not linear, then the output signal will not be pure sinusoidally, and its peak portion of the output signal becomes flat. So now the magnitude, now due to this non-linear non-sinusoidal signal, it generates harmonics in which many numbers of frequency will generate with the fundamental frequency like 2f, 3f, 4f, etc. etc. Now the magnitude of this harmonic frequency is reduced with increasing frequency. Now here we are as shown in this figure, the characteristics of these devices is not linear. That means it is dynamic characteristics of the devices is non-linear characteristics. Now due to this non-linear characteristics, the output signals peak portion becomes flat. That means we reduce the magnitude of the output signal. So now this type of distortion occurs due to the non-linear characteristics of the active device. That's why it is called non-linear distortion. Now due to this non-linear distortion which decrease in the amplitude of the output signal, and due to this harmonic signals are produced. Now that's why it is called harmonic distortion.